What is up, everybody? We are on to 5.5, triangle inequality structure. Now, in the last video, we talked about how to organize side length or angle measure based off of the structure of the triangle, meaning if you knew all the side lengths, you could technically order all the angle measures from least to greatest or greatest to least. If you know all the angle measures, then you can order all the sides from least to greatest or greatest to least. All right. Now we're going to talk about the actual construction of a triangle, and we're going to look at the rules. Previously, I had said you can't just pick any three sides or any three lengths and make a triangle. There are rules to the structure. For example, I can't use one side that's 1,000 and one side that's 10 and one side that's 5,000. Like that, you can't make a triangle with that drastic of difference in side length. So what exactly is the rule to making a triangle? And it's actually pretty simple. Okay, the sum of any two sides, so the addition of any two sides of a triangle, must always be greater than the length of the third side. Meaning, if I have three sides, if I add up any two sides, the result of that has to always be greater than whatever the third side was that I didn't add up. So the sum of any two sides of a triangle must always be greater than the third side. So let's go ahead and take a look at this diagram right here. And I color-coded these so you can kind of follow along a little bit easier. So PQ is blue, QR is purple, and PR is green. So, first things first. Blue plus purple has to be greater than green. So PQ plus QR has to be greater than the length of PR. Now, if there's three different sides, how many different ways can we organize or rearrange this equation right here, right? Because it has to be true for every different way we can do it. So another way is blue plus green has to be greater than purple. So far there are two different scenarios that we have to test. Is there another way we can rearrange this? Blue has not been on the other side of the equal sign yet, or the inequality sign. So purple plus green has to be greater than blue. And that is all the ways that we have to check it. So there's three different equations that you have to check. And if any of those become false, because remember, inequalities can also be looked at as true or false, right? Like 5 is greater than 2, true. But if you have 5 is greater than 7, that is a false statement. And if any of these ones are false, then those lengths cannot be used to make a triangle. Okay? And guys, the reason that that's true is because if, say we have 3 lengths, right? And then my next length is like this long, okay? Then that's not going to work. Yeah, it could overlap and we could make a triangle, but then the entire length of this side wouldn't work, right? It would only be however long this side would be. So there is limitations to the lengths sides can be to make the triangles, okay? So it's a really simple test. It doesn't take very long at all. And as soon as you find that one is false, you can stop, or you might have to go through all 3 of them. Now, some people might be able to do this in their head really quickly. Some people might have to write it out. It really is up to you. I always just write them out just for kind of like the sake of doing it, and so I have the proof right in front of me. So easiest way to do it is the order it's given to you. I always do that one first. So 15 plus 16 greater than 30. Is that true? Yes, it is. Then what I'll do is I'll exchange the last and the second and last one. So 15 plus 30 is greater than 16. That's obviously true. And then finally, I'll exchange the last and the first one. 16 plus 30 greater than 15. That's always true. So can these 3 lengths make a triangle because we have 3 trues? Yes, they can. Easy, right? Super straightforward. 8, 11, and 2. Okay, so 8 plus 11 is greater than 2. That's true. 8 plus 2 greater than 11. 8 plus 2 is 10. 10 is not greater than 11, so that's false. So can these three lengths make a triangle? I don't even need to check the third one. The answer is no. Okay, so this is the first part of the homework. It's very straightforward. It's very simple. All you got to do is test your equations. Once you find they're all true, you can say yes, but as soon as you find one that's false, it's no, as regards to the sides can't make a triangle. Now the next phase in this is, what if we have two sides and we're trying to find the range of the third side? Because as you can tell, right, like if I have two sides of a triangle, the third side length kind of determines on how much this angle opens or closes. Because if I close that side length a little more, like this, then if the purple and this highlighted blue one were the same length, notice that the third length, that blue side, so this side one right here and this here, those are different lengths. So the mouth, or how you open the angle, changes what the third side length can be. So there's not just one, there's a ranges of length that the third side can be. So the question is, how can we find that range? All right, so let's say we know two sides of a triangle are 3 feet and 7 feet. How small can the third side be? Okay, so we have a triangle that has a side of 3 and a side of 7. So we're trying to first figure out how small can that third side be. Now, if we did it like this, and it's going to be an equation, all right? If I did 7 plus x is greater than 3. Because remember, guys, we're still using that equation concept that two sides added up have to always be greater than the third side. But when I solve this inequality for x, I get x is greater than negative 4. But the side of a triangle will never have a negative number. So the way that we find the smallest side is your smallest side, the smallest range. The smallest side plus the unknown side is greater than the larger of the two that you know. So the smallest that you know plus your unknown is greater than the larger of the two that you know. So we know 3 and 7, so 3 plus our unknown is greater than 7. Get x by itself, x is greater than 4. So the smallest that our side can be is anything greater than 4, like 4.1 or 4.05. Because if we were to test our equation, 4 plus 3 is greater than 7, that's actually false, right? Because 7 is not greater than 7, it's equal to 7. But if I did 4.1 plus 3 is greater than 7, that would be 7.1 is greater than 7. That is a true statement, okay? So our smallest it can be, the smallest it can be is anything greater than 4. But what if we want to figure out how long the third side can be? So we're looking for our maximum value. Well, we're still using the same type of equation where it's going to be a side plus a side has to be greater than the third side. But in this case, we use the two that we know. 3 plus 7 greater than x. And this gives us the maximum value that our third side can be. So 10 is greater than x. So x has to be less than 10. And what we do is we combine these two values to make an inequality statement. So x has to be greater than 4, but less than 10. And that's the range of our third side of our triangle if we know that the two sides have to be 3 and 7. So it can be anything greater than 4, but it has to be less than 10. And the reason it has to be less than 10 is because if I do 3 plus 7 is greater than 11, that's a false statement. We can't make that triangle. Okay, but if it was 9.9, 10 is greater than 9.9, that's true. That falls into that inequality area right there. Okay. So kind of recap this, it's always the smallest that you know plus your unknown is greater than the larger of the two that you know. That gets you your minimum value. And then the two that you know, add them together, greater than your unknown. And it'll be like that every single time. Every time. All right? So let's look at your homework. So your homework, there's two parts to this homework. The second part is kind of like a review, and I'm not going to require you to do it all at one time. But the first page of the homework, I think it's like 1 through 19, that's what you're going to be responsible for. So let's look at number 1. Okay, so the first 10 problems, they're just asking, can the three lengths make a triangle? Right? And again, it's kind of up to you how much work you really want to show on this. It might be a question that's multiple choice. It might be a question that you have to actually show your work out. Remember, there's 3 different equations we have to test. 15 plus 12 is greater than 9. That's true. 15 plus 9 is greater than 12. That's true. 12 plus 9 is greater than 15. That's true. So yes, these can make a triangle. Okay. Let's look at number 7. 5 plus 10 is greater than 15. Is it greater than or is it equal? It's equal. So right away that's false, so no, those ones cannot make a triangle. All right. I don't think I need to do any more of those. I think you guys got it. Pretty straightforward. Let's do another one of these down here where we're trying to make our inequality statement. We're trying to find the range of the length of our third side. So what I do is I'll just add a variable, x, okay? And I usually always find the minimum first. So remember, to find the minimum, it's the smaller of the two that you know plus your unknown is greater than the larger of the two that you do know. Subtract your 9, so x has to be greater than 6. Then to get my maximum, it's the 2 that I know added together is greater than my unknown. 9 plus 15, that's going to be 24, so x has to be less than 24. We're going to combine these two to make one inequality statement. So x has to be greater than 6, but less than 24. All right. Let's do one more, just for fun. Okay, 11 and 12. Let's throw in a y this time. Change the color, break it up a little bit. So 11 plus y is greater than 20. So y has to be greater than 9. Then 11 plus 20 is greater than y. So y has to be less than 31. Combine those to make our inequality statement. Y has to be less than 31, but greater than 9. And guys, really important that you put these in the correct order in regards to, you don't want an inequality statement that doesn't make sense. Like, so you don't want to put 6 is greater than x, but less than greater than 24. Like, don't do that, okay? Make sure you're writing it out so that it reads right. X has to be less than 6, but greater than 24. Hopefully this is pretty straightforward. Let me know if you have any questions.